Right. So this reaction is transesterification. It's a reaction in which we have a different alcohol replacing the alcohol part of an ester. So typically we've seen this on regular open esters. We have something like that. The rest of the molecule, and this alcohol portion gets replaced with another alcohol. However, in this case, we are now faced with a cyclic ester, which here is the alcohol part that is going to be replaced. But because it is a cyclic ester, the alcohol is going to still stay with the molecule. The alcohol is going to stay with the molecule. And so it generally begins with the protonation of the carbonyl carbon to get it activated. So we have the protonation. So this picks up the proton, and that gives us our first intermediate. Once that intermediate is formed, then the ethanol now we have going to now attack the carbonyl carbon. So it's going to attack this carbonyl carbon right here. It's going to attack the carbonyl carbon right there. So this goes in to attack the carbonyl carbon, creating a feed bond. But we know carbon should only have 4 bonds, so therefore one of the pi bond right here will break open. And that gives us the next intermediate. Comes on out. Now we have, okay. So now remember, we still have the alcohol molecules in solution. We still have the alcohol molecules. In solution. And so those will now act as a base to pick up the proton. Bond breaks to feedback. That gives us the next intermediate, ethanol here. Now the regenerated acids now would protonate. The regenerated acid is now hanging in solution right here. We'll have that regenerated acid that is still in solution in there. And so now this acid is going to be able to protonate the oxygen right here. Lone pair of electron picks up the proton, and this bond breaks back to regenerate our ethanol. So have this intermediate, and now we have a positive charge on that oxygen. So the carbon right here, the carbonyl carbon, is now very unstable with so many oxygen, and so what will be the result is that the carbonyl will try to reform to get that carbonyl carbon stabilized again. And so the lone pair of the electrons here will drop in here to regenerate our carbonyl functional group. And this time, remember, this is the alcohol that we brought in. So the leaving alcohol is now, this bond now breaks. Like I indicated, it's it's a cyclic ester, so that alcohol stays with the molecule. And that this now gives us the intermediate that's going to lead us to the product. Going to give us the intermediate that leads us to the product. So we have this. So we can try to count our carbon. So from the carbonyl we have 1, 2, 3, and 4 carbon atoms. So we can say we have an OH group right there. That carbonyl carbon is regenerated. We have the hydrogen is still intact, So we now have a positive charge here. And then on this other end now we have our ethanol molecule. And so the ethanol molecule in solution, is now able to pick up the proton and regenerate the acid, since this reaction is acid catalyzed. So this is able to pick up that proton that breaks in there, regenerating the acid, and we get our product. And that is the product of that reaction.